Welcome to part 3 of the Best Way to Learn Python tutorial series. In this third episode, I'll be introducing variables in Python, control flow, that means while loops, for loops, and also if clauses. And we'll also be building an example. In matplotlib, we'll be plotting a parabola, so we'll be doing something visual with which we'll be using all the techniques that I'll explain right now. Okay, so following part 1 if you're using Linux, or part 2 if you're following Windows, I'm going to start up Anaconda. So I'm on Linux, which means I have to go source bin activate and then specify the Anaconda directory. Under Windows, I don't have to activate. I can run IPython directly because it's on my path. And then in both Linux and Windows, I'm starting up IPython Notebook, but I have an extra parameter I have to specify, and that's --pylab equals inline, because I'm going to be making use of inline matplotlib plots. Okay, so that's IPython Notebook, pylab equals inline. Okay, so when I do that, it will open a new browser window. And then in this browser window, I'll be making the notebook for this episode. So there we go. New notebook, and I'll be calling this Apply part 3. Okay, so to show you what we're going to end up with, I'm going to show you, well, before we start, actually, we have to do that invocation to change the print statement to a print function. Remember, from --future import print function. Now I'm all set. And now let's see what we're going to be doing with that plot. Let me just cut and paste the code over here, and then later on I'll explain what exactly is happening. So look, you'll all remember this from school. It's just the standard parabola equation, and we'll be using Python and matplotlib to plot this based on the actual mathematical the equation defining the parabola. Okay, but before we get there, we have to do some background work. So let's start. Okay. In Python, unlike many other languages, I don't have to declare the type of my variables. It's a dynamically typed language, which means I can just assign a value to a variable. And in Python, we say that I bind the variable to a name, and then Python will figure out what to do with it. Everything's an object in any case. So to give an example, I can go a equals 1. The value of a is, and execute that. Okay, and now I can go and overwrite that. So I can, right after I bind a to 1, I can bind it to a floating point number, for example. And look, that's now, because I bound it to 0.3 after I bound it to 1, that's what I'm seeing in my print statement. But, so that's an integer or a float. I can also go and say, well, I don't have to tell Python what type that is. I just assign the value, and it'll take care of the rest. So there you see it's outputting a string. So that's how variables work in Python. I can reassign or rebind them at any point. We'll talk about scope, the variable scope, a bit later when we continue with functions. Okay, but that's for a bit later. So I can now I can obviously also assign arbitrary expressions to my variables. So here I'm going a equals 4 divided by 3. It's just and I get 1, which is a bit strange because 4 divided by 3 is not 1. So this is a little Python thing, because both of these are integers. It's doing an integer division. So 3 goes into 4 once, and then there's a rest, but it's not showing me that because I'm doing an integer division. As soon as I change one of these numbers to a floating point number, then it'll know I want to do a floating point division, and it'll give me the real floating point answer. Okay, so we have these basic variable types, the integers, floating point, strings, and then we start with lists, which is a really powerful Python data type. So a list is like an array in other languages. Sorry, I'm typing blind here. And so as you might be used to from C or other languages, I can use a list to store any number of elements. What's nice about Python lists is that I can store any type of element in there. So there you see I've made a list with 2 integers and a string, and I can now also add a floating point just to prove my point. And now I have a list with 2 integers and a string and a floating point. Okay, and this is, so I'm using square brackets, so it's a list. That means it's mutable. It means I can change my second element, so everything is 0 based. So the first element is 0 and the second element is 1 and so forth. So let's just change that 2 into another string. And then print A again. So there you have it. So I can use lists to store arbitrary collections of objects, and there's no limitation on the type. I can even stick lists inside of lists and do that up to any depth. And it's a list with square brackets. It's mutable, meaning I can also change elements after I've defined that list. Python has another iterable. It calls everything that it can iterate through an iterable. That will become clear later. It's called a tuple. So let's just define one of those. And the only difference is it uses parentheses instead of square brackets. The general idea is the same though. I can also store different types. Still work. The big difference with the tuple is that it's not mutable. So if I try to change any element, which is a valid operation with a list, I get an exception. This is a typical way for Python to report that that's an error. So it's telling me, listen, it's a tuple, does not support item assignment. And we say then it's not mutable, it's not changeable. So once you've defined a tuple, it's that way forever. Obviously, I can reuse B. I can rebind B to anything else, but that's not actually changing the tuple. Just store it somewhere else, C equals B. And now I can go and give B anything else. But C itself, or the actual values inside of that tuple, I can't change them in any way. Okay, so that gives you the list and the tuple, which are two, they're actually all important Python types. And now we're going to look at iteration. So now I have, let's use the A I have already defined. So let's say I'd like to perform some operation on each element of A. So I would want to iterate through, you call that iterate through A. So I want to go through A, and then somehow I want to apply the same operations to every element. And what I use in Python for that is for. So I go for I in A, print I. So what that's going to do, it's going to go through list A, which contains those 4 elements, 1, another string, cats are not nice, 0.3. And then inside of that loop, the current element will be bound to variable I. So let's just see what that looks like. And there we go. So what's happening there is it's going through each element in that list, and inside of that loop, I can do any operation. So what you will have noticed by now, if you haven't before, that in Python, indentation is very important. That's how it knows that the sprint should be inside here. So what you'll see here is that hello there is printed 4 times, because that's how many elements I have in my list, and after the loop is printed only once. And the only reason, or the only way that Python knows that the one is inside the loop and the other one is outside, is because of the indentation. So this makes for clearer code. So I can even do that. Same idea. So the indentation is important. That's how Python knows what belongs inside a loop, or what belongs inside any block of code, or a function for that, for example. Okay, for is this basic way in which I can iterate through any iterable. So that can be a list or a tuple. Now you might be asking yourself, how can I make a normal for loop? In other words, going from some start integer, some end integer, and then iterate through there. It works exactly the same way, except what I do then, I use range. So range is a Python function that's going to generate a list of numbers for me. This is an interesting thing in IPython. This is d equals range. If I now press tab, or if I just wait, it gives me help on that function range. So I can see I just have to specify stop, or I can specify start, stop, and step. Let's just do the first form. So I'm just specifying the stop number. What does it do? Oh, that's because I'm not supposed to do that. I should do this. So what's happened here is that Python has gone, and because I called range, it's gone and generated by default starting from 0 and going up to just before the stop number. This is standard in all of Python, in list slices, which we'll be looking at later, in range, in every kind of iteration. It always stops right before the stop number. Okay, let's just see if we can do something else. Let's start at 2 and go to 10, and let's do so in jumps of 3. So it starts at 2, so the first start number is always inclusive. It will never ever reach the stop number. It will always stop before the stop number, wherever that is. And now it's jumping with 3. So it went 2, plus 3 is 5, plus 3 is 8. And then 11, of course, is too high, so I did not print that out. So that's how range works. And this is also how I can do any kind of numeric for looping. So it's all nice and consistent. Then I go for I in range 10. So there we have it. We have a nice numbered for loop. But you'll see it's consistent. What's happening here is it's generating in place, it's generating a list from 0 to 9, and then it's iterating through that. So that's how I do for loops in Python. But obviously now I can also go and say, well, you know what, let me go from 10 down to 0 and with a step of -1. So we're going to step in the downwards direction. So it's starting at 10, it always starts at the start number, and counting down with -1, so 10 minus 1 is 9, and so forth, and it never ever reaches the stop number. It always stops just before it reaches the stop number. As long as you know that, you'll know how to interpret all of this Python code. Okay, so now I think we only need to do, we can use this, and I can also show you how the if works. So let's, for example, say that 7 is our lucky number. I go if I equals 7. So what have I done now? I have a loop in here, and inside the loop, every time it goes through, it picks another element, so it's going 10, 9, 8, 7, and so forth. It asks, is that the current element, is it equal to 7? And if that's the case, then it prints, that's my lucky number. And you see exactly that happened. It started at 10, counted down to 9, 8, reached 7, said, that's my lucky number, that statement. Right after, printed 7, of course, we expect that. And then finish the loop. Just, I can also, obviously, every if has to, or can have an else. So let's change that and say if it's my lucky number, it's not a very clever program. So what's happening now is I'm showing you that an if can also have an else. So what happens here is it's doing the same. It's going through the whole loop through each and every element. If it's equal to 7, that's the lucky number. So it's the saying that's my lucky number, but it's not going to print it because it's only going to print it if it's not 7. So you have to read this. You can read this like an English sentence. If I is 7, print that's my lucky number, else print the number. So that's like if I is not 7. So in all other cases, that's how the else works. You can also have an elif. So what's happening now is that when it sees a 7, it's saying that's my lucky number. If it sees a 5, it says that's not a bad number either. And for all other numbers, it's just printing the number. So you can always use this construct. So this is, in fact, if I kind of have to kind of explain it in normal English, it's saying if I is 7, do this. Else, only if it's 5, do this. Else, and that means all other cases, print the number itself. So that's how the if statement works in Python. Okay, I think we've covered. I think we only need to look at the dictionary, the Python dictionary, which is a really interesting Python data type. So what the dict is, it's actually a map, meaning it can translate from any hashable object to any other value. What does that mean? Let's just see it in practice. So I've defined a dictionary, a dict. Let's just see what that looks like. If I go type E, you'll see it's a dict. Let's see what it does. So if I ask E, what's the answer for cat? It tells me 0. If I ask it, what's the answer for dog? It tells me 1. If I ask it something it does not know, it gives me a key error because dog2 does not exist in this dictionary. So it's a dictionary. It looks up from the word I give it to the answer I want. And why this is interesting? Well, for many reasons. It's a really, really flexible data structure, but it's also really, really fast. So it takes complexity 01 to look up in an arbitrary sized dictionary to look up the key that I'm giving it. So you can use that if you have if you need any kind of lookup table in your code, you can use a dictionary for this purpose. It's really, really fast, it's really efficient, and it's also flexible in this way. Okay, so that was a dictionary. Now we have to get back to plotting our parabola, and you should understand exactly what's happening there based on all of these data types and control flow structures. Okay, so remember we started IPython with IPython Notebook --pylab equals inline. We don't actually need that pylab. We'll have it here for completeness sake. Okay, so what's happening here? Let's just see what's... Oh, sorry, it's me again. I'm very used to Python 2.7. There we go. So in this case, what I want to do, I want to plot a parabola. And you'll remember from school, this is another nice function of IPython, is I can do math, or I can do very nicely typeset math. You'll remember that the parabola is y equals ax squared plus bx plus c. See, it nicely typesets that for me. Remember this? So I go on the x-axis, and for each x, I square it, multiply it with a, and then add b multiplied by x, and then add c, and then I will get the y value. And this is exactly what we're going to do now in code. So let's just start by generating some x's for us to use. So I decided to go from -10 to +10, and therefore I have to specify -10, and the stop number is 11. You remember why? Because it always includes a start number and it stops just before the stop number. So this will go from -10 through 0 up to 10 positive. Okay, you can see also there, because I've printed x, you can see it's made this nice list for me. Okay, let's take that away. And now we want to build up y. So first we make an empty list. I didn't show you this, but you'll see that right now. I'll make an empty list. I'm going to add to this list as I go through all the x's and calculate y equals ax squared plus bx plus c. Okay, here I have some arbitrary values for a, b, and c. So a is 2, b is 3, and c is 10. That's the y-intersect. And now I'm using my for construct. Remember, x is just a list going from -10 to +10. So in every iteration of this loop, xi will have the value of the next element. So it's going to start at -10, and then -9, and then -8, and so forth, up to +10. And each time, I just say, I calculate y. So remember, y is a multiplied by the current x squared, which in Python I do with **, plus b multiplied by x plus c, right? So that's going to give me y. To make it all just a bit more clear, let me just assign it to a temporary variable like that, and then do that. Okay, and just to make it even more clear, I'm going to print it out for you during the loop. Let's just say x and yi, xi and yi. So it's going to print at every loop. It's going to print the x value and the corresponding y value. And then what append does, append takes that element and it appends that to my list. So after the first iteration, the y list will have one element. After the second iteration, it will have two elements, and so forth. And when it's finished the loop, there will be just as many elements in in the list y as there are in the list x. Okay, let's just do that and see what it looks like. There we go. So it starts at -10, and that gives a y value of 180, and so forth. Okay. So by the end of this, and I can show you that too, this is the beautiful thing about playing with a notebook, is that you can experiment like this. So let me just print out the y. So by the end, I now have a y, which is exactly the same length as the x. Let's just see, len y, that gives me the length. You can see it's both of them are 21 elements, going from -10 through 0 to +10. That's exactly what I want. Okay, we're almost done. So PyLab is part of matplotlib, and it allows me to plot, to make very nice high quality plots. So I'm just going to take the X, that's what PyLab wants, or plot wants, look. So I can give it X and Y lists, and it'll plot those for me. Okay, so I'm just giving the 21 elements in X, 21 elements in Y, and then I'm drawing a grid that's giving me these nice dashed grid lines, and then I'm giving it my X label and my Y label, and just to be fancy, I'll take this bit of math typesetting over here, and I'll use that as my Y label. There we go. And there you get this beautiful plot with, on the x-axis you have x, and on the y-axis you have the full equation, and there you can see the parabola, just as your mathematics textbooks at school predicted it would look. The nice thing about this, I can obviously now go and see what happens when, for example, I experiment with b. If I make it 0, then obviously my parabola will be symmetrical around the y-axis. And by increasing or decreasing the a, I can change the steepness of my parabola. So it's rescaling the axis, but you can see now it's intersecting at the -10, it's intersecting the y-axis at 500, whereas if I go back to a equals 2, it's intersecting at 200. And I can play with a C, which is the y-axis intersect. In the middle, there we go, nicely at 50. So there we go. So this part 3 was a lightning introduction to a whole bunch of Python variable or data types, and you saw that I don't really have to worry about declaring types. I just assign a value to a name or a variable, and in Python we say that I bind a to this value 1, or I bind it to the value 0.3, and so forth. It doesn't matter what this type is. Python will take care of it. Okay, we looked at this division behavior, that in Python, if it thinks you want an integer, it's going to do an integer division. Also, it will give you a floating point. We started looking at lists, which are these really flexible collection structures in Python in which you can store anything, and you can also change them. You can mutate them, so they're mutable. We looked at tuples. They're like lists, except they're not mutable. They're interesting. The nice thing about tuples is that they're hashable. I'm not sure if we can hash a list. So I don't think so. I think that's the problem. Okay, so that's an interesting behavior. We can't hash a list, but we can hash a tuple. So what does that mean? Well, many things. There we go, it's got a hash without any errors. It means, for example, we can use a tuple, we can use as a key in a dictionary. But we can't use the list as a key in a dictionary. So that's one of the differences between mutable and unmutable types. Okay, we looked at tuples, we looked at for loops, and it's always the same. We always have for, and then the loop variable in, and then an iterable. And what's going to happen is it's going to go to that iterable, and it'll at each iteration, it'll assign the next element of that list or that iterable. It'll assign to my loop variable, and then inside of the for loop, I can do anything to that loop variable. And then we looked at how we can also do numbered for loops or for iterations using range. And then we also looked at the if else clause, how that works inside of such a for loop. Also remember that indentation is important. This is how Python knows what's inside a code block and what's not. And we briefly looked at a dictionary, which is a really flexible map type that allows you to do really quick lookup tables from any hashable type to any other value. So you can even make this hashable type an object. So you can look up really quickly an object inside of a dictionary. Okay, and then we ended all of this by drawing from basic principles from the math by drawing a parabola using matplotlib. So that was part 3 of this tutorial. Let me know in the comments if you'd like to see anything else. In the next parts, we'll look at, for example, object-oriented programming. That's how to make classes and objects in Python, and a whole bunch of other interesting goodies. But I'd like for some feedback from you to know what you're really interested in, so we can make an episode about that. Thank you very much for listening.